Reaching for the stars, manufacturing beyond Earth. Space manufacturing is about building things in space, using resources found on the Moon, Mars, and asteroids. Imagine mining asteroids for precious metals, factories in orbit constructing massive spacecraft. Space manufacturing offers a solution to our earthly constraints. It allows us to access resources beyond our planet. This technology holds the key to expanding our civilization beyond Earth. The journey into space manufacturing is already underway. Visionary entrepreneurs like Elon Musk and Jeff Bezos are leading the charge. Their companies, SpaceX and Blue Origin, are developing reusable rockets. Governments are also playing a crucial role, investing in research and development. International cooperation is essential for success in this new frontier. We are on the cusp of a new era in space exploration. Space manufacturing can help us address some of humanity's biggest challenges. Imagine space-based solar power providing clean energy for Earth, mining asteroids to alleviate resource depletion. Space manufacturing opens up a universe of possibilities. By embracing this new frontier, we can secure our future and unlock the boundless potential that space holds. Imagine a giant robotic arm, suspended in the vacuum of space, carefully laying down layer after layer of molten metal. This is the power of 3D printing in space. It allows us to construct large structures without launching them from Earth. One key advantage is its versatility, using materials from plastics to metals. This technology empowers us to be self-sufficient in the challenging environment of space. Space is teeming with valuable resources. The Moon, Mars, and asteroids contain vast reserves of water ice, metals, and other essential elements. Water ice can be used for drinking water and rocket fuel. Metals like iron, titanium, and platinum are abundant in asteroids. In situ resource utilization, ISRU, is crucial for sustainable space exploration. By utilizing local resources, we reduce our reliance on Earth and pave the way for long-duration missions and permanent settlements. The International Space Station is a testing ground for technologies that will enable us to live and work in space permanently. Experiments conducted on the ISS are paving the way for space manufacturing and resource utilization. One notable experiment involved 3D printing with regolith simulant. The ISS has also hosted experiments on growing food in space. This research is crucial for developing sustainable food sources on long-duration missions and future settlements. The knowledge and experience gained from the ISS are invaluable as we venture further into our solar system. Imagine a future where humans live not just on Earth, but amongst the stars. Picture vast, rotating habitats, orbiting the Earth or nestled within lunar craters. Building a habitable structure in space presents unique challenges. Space manufacturing offers innovative solutions to these complex challenges. One promising approach is to use 3D printing technology with materials found directly in space. These habitats, built from the very fabric of the Moon, could house entire communities. Sustaining human life in space requires more than just shelter. We need food. Hydroponics, a method of growing plants in nutrient-rich water without soil, is already being tested on the International Space Station. This method is highly efficient, requiring less water and space than traditional agriculture. On the Moon and Mars, the potential for agriculture exists using the soil itself. Imagine large, pressurized greenhouses on Mars, bathed in sunlight, where future Martian colonists tend to rows of potatoes. Space farming goes beyond just providing sustenance. It plays a vital role in the psychological well-being of future space travelers. In the closed-loop environment of a spacecraft or a space habitat, waste management is not just about tidiness, it's about survival. Space manufacturing plays a crucial role in developing efficient recycling systems for space. Imagine compact, self-contained units that can process organic waste into fertilizer for hydroponic systems. Water recycling is even more critical. Advanced filtration systems could purify wastewater for drinking, hygiene, and even hydroponics. Beyond basic recycling, space manufacturing could allow for advanced upcycling techniques, transforming plastic waste into filament for 3D printers. The ultimate goal of space manufacturing is not just to survive in space, but to thrive. This means creating a closed-loop ecosystem, a self-sustaining environment where resources are constantly cycled and reused. Imagine a space habitat where plants clean the air, their waste products used to fertilize algae, which in turn generate oxygen. Water is continuously recycled, waste is transformed into resources, and the habitat itself is built from materials sourced directly from space. Achieving this level of self-sufficiency requires a deep understanding of ecological principles and the ingenuity to adapt them to the unique challenges of space. By learning to utilize the resources of space efficiently and responsibly, we pave the way for a future where humanity can not only survive beyond Earth, but thrive amongst the stars. Imagine a future where we construct massive spacecraft, not on Earth, but in the vacuum of space. Constructing spacecraft in space offers a multitude of advantages. Freed from the constraints of Earth's gravity, we could build structures far larger and more ambitious than anything possible on the ground. Utilizing resources mined from asteroids and the Moon, we could create self-sustaining spacecraft. The challenges of interstellar construction are immense, requiring advancements in robotics, automation, and new materials. But the potential rewards, the ability to reach new star systems and explore the galaxy, make this a challenge worth pursuing. One of the biggest hurdles to deep space travel is fuel. Space manufacturing offers a solution: space-based propellant depots, strategically positioned throughout the solar system. Imagine a network of fuel stations in orbit around Earth, the Moon, and Mars. These depots, supplied by water ice mined from asteroids or the lunar poles, could provide a much-needed refueling option for spacecraft. This would drastically reduce the amount of fuel needed for launch from Earth, making space travel more affordable and efficient. Space-based propellant depots would not only facilitate travel within our solar system, but could also serve as stepping stones for interstellar missions. Mars, the red planet, has long captured the human imagination. Space manufacturing is key to transforming this vision into reality. Establishing a permanent human presence on Mars requires building a sustainable infrastructure. Imagine robotic 3D printers deployed on the Martian surface, transforming local regolith into sturdy shelters. Imagine vast solar arrays, capturing the Martian sunlight to power greenhouses where crops thrive in Martian soil. As our capabilities in space manufacturing advance, we can envision not just outposts but thriving Martian cities. The relentless grip of microgravity. Space presents unique challenges. Microgravity, the near-weightless environment, is one of the most significant. It looks fun but poses serious problems for manufacturing. Gravity helps molten metal flow predictably and tools to stay put. In space, these assumptions no longer hold true. Liquids form floating globules, dust particles can damage equipment. Simple tasks become complex maneuvers. Scientists are developing new alloys and techniques for space. The invisible threat: radiation beyond Earth. Beyond Earth's protective atmosphere lies another danger: radiation. The sun constantly bombards our solar system with harmful particles. Cosmic rays from distant supernovae add to this invisible threat. This radiation poses a serious risk to both humans and equipment in space, and it presents a unique challenge for space manufacturing. Astronauts working on construction projects in space would be exposed to higher levels of radiation than on Earth. This could increase their risk of cancer and other health problems. Shielding materials, such as lead or water, are heavy and expensive to launch from Earth. Finding lighter and more effective radiation shielding solutions is crucial. Radiation also affects the materials used in space manufacturing. It can degrade the performance of electronics, weaken structures, and even cause materials to become brittle over time. This means we need to develop radiation-resistant materials and design structures that can withstand prolonged exposure to the harsh space environment. One promising solution is to utilize resources found in space for radiation shielding. Lunar regolith, for example, is rich in materials that can block radiation. Imagine building habitats on the Moon or Mars, using layers of local regolith as a natural shield against the invisible threat from space. The cost of ambition funding and collaboration in space. Space exploration has always been a costly endeavor. International collaboration is essential to share the costs and accelerate progress. Collaborative projects like the International Space Station demonstrate the power of joint efforts. However, international collaboration in space is not without its hurdles. Companies like SpaceX are driving down the cost of space travel. Investing in space technology ensures the long-term survival of our species. AI, the intelligent assistant for space manufacturing. Space manufacturing presents numerous challenges. AI analyzes data, learns from experience, and makes autonomous decisions. It adjusts the printing process on the fly, ensuring a flawless habitat. AI plays a crucial role in resource identification and extraction. It assists in design and optimization, ensuring robust structures. Robotic pioneers, building beyond Earth's limits. While humans dream of walking on Mars, the initial heavy lifting will be done by robots. These robotic pioneers will be our tools in this new frontier. Imagine spider-like robots assembling a solar power station in orbit. Controlled by AI, they weld beams and attach solar panels. On Mars, robotic miners extract water, ice, and minerals. Autonomous rovers transport resources for processing. Equipped with advanced sensors, they adapt and collaborate. They pave the way for humans to follow. A global endeavor, international collaboration and space law. Space, as declared in the Outer Space Treaty of 1967, is the province of all mankind. This principle of shared ownership and responsibility is more relevant than ever. The challenges of space exploration are too great for any one nation to bear alone. Imagine an international space station, designed and built by a consortium of nations, dedicated to research and development in space manufacturing. International collaboration extends beyond just research and development. It also encompasses the establishment of legal frameworks for the responsible use and allocation of space resources. The challenges ahead are many, but so are the opportunities. By embracing international collaboration, we can unlock the potential of space manufacturing and usher in a new era of human prosperity and exploration amongst the stars. A new dawn for humanity. As we stand on the cusp of this new era, the possibilities seem limitless. Space manufacturing is rapidly becoming a tangible reality. The implications for humanity are profound, promising solutions to pressing challenges. Imagine a future where the resources of our solar system are within reach, where asteroids provide raw materials for a new age of prosperity. Picture vast solar energy platforms in orbit, beaming clean power back to Earth. This is about pushing the boundaries of human ingenuity and creativity, a chance to rewrite the story of humanity among the stars. The ethical imperative of space exploration. With great power comes great responsibility. As we venture further into space and develop the capabilities of space manufacturing, we must proceed with caution and a deep sense of ethical awareness. The decisions we make today will shape the future of space exploration for generations to come. The resources of space, while vast, are not infinite. We must avoid the mistakes made on Earth, where short-term greed and unsustainable practices have led to environmental degradation and resource depletion. Imagine an international framework for space resource utilization, ensuring equitable access and responsible management for the benefit of all humankind. The potential for conflict over resources, territory, and strategic advantage in space is a real concern. We must establish clear legal frameworks and international agreements to prevent the militarization of space and ensure that this new frontier remains a domain of peace, cooperation, and scientific discovery. As we expand our presence in space, we must also consider our ethical obligations to potential extraterrestrial life. The discovery of even microbial life on another planet would be a momentous event, requiring us to re-evaluate our place in the universe and proceed with humility and respect for the unknown. To infinity and beyond. The human spirit is defined by a relentless curiosity, an unyielding desire to explore the unknown, to push the boundaries of what's possible. Space manufacturing is the key to unlocking a future where we are no longer bound by the limits of our home planet, where the stars themselves become stepping stones to new worlds and new possibilities. Imagine generations of humans born in space, their bodies adapted to the challenges of microgravity, their minds accustomed to the vastness of the cosmos. Imagine them looking back at Earth, not as the only home they've ever known, but as the cradle of their civilization, a reminder of where they came from and how far they've come. The challenges ahead are immense, but the spirit of exploration that burns within us is far greater. By embracing innovation, fostering collaboration, and holding fast to our ethical principles, we can make this vision of a spacefaring future a reality. The journey of 1,000 light years begins with a single step. Today, we take that step, not just for ourselves, but for all those who will come after us, for the future of humanity amongst the stars.